All right, thanks a lot. It's a pleasure to be here, and I'm just going to take a few minutes to talk about how knowledge graphs and their combination with large language models and other neural nets, how that fits into the overall picture of artificial intelligence and how it fits into both the past and the future of AI. And I think it has a quite powerful and interesting role to play. So I'm more interested in the future than the past, generally speaking, but I also think a bit of historical context can be valuable. The AI field, as such, goes back to the late 1950s, although there was activity before that. I think Norbert Wiener's book, Cybernetics, was 48 or something, the middle of the last century, which laid out many of the principles of neural networks and how the same cognitive algorithms could operate in biological and engineered systems. And almost since the beginning of the AI field, you've had these two strains going on of sub-symbolic versus symbolic AI. And it's been framed in different ways, neural on the one side, rule-based or logical on the other side. But I think that the core of the dichotomy has been on the neural or sub-symbolic side. You're building AI systems that are composed of tiny little components that have no clear or comprehensible semantics. And then, things with clear human meaning arise from the learned or self-organized combination of a bunch of these little tiny elements. And the neurons in a huge neural network, like an LLM or a Hopfield network or a convolutional neural net. I mean, these are an example of that. The fundamental elements, the neurons, are at a smaller scale than the humanly comprehensible semantics. So the humanly comprehensible stuff has to emerge out of these very low-level components, right? And the other strain that's been there since the mid-1960s, at least, I mean, arguably earlier, symbolic AI. You're building software systems whose core elements, many of them have a clear semantic meaning. So if you have, say, a neural net system, a sub-symbolic system for reasoning about cats and dogs, there's not necessarily a cat neuron or a dog neuron. There might be, but a lot of the fun is in large-scale patterns of activation among many neurons that constitute the network's understanding of what a cat is, right? Whereas in a symbolic system, you're likely to have, like, here's a cat node, here's a tail node, here's a linker node representing part of the tail is part of the cat. And both of these forms of AI have been valuable. They've both led to a host of commercial applications back to the 70s and 80s, and they both have interesting sort of psychological and biological stories to them, right? I mean, clearly the sub-symbolic story resembles aspects of what's going on in the human brain. Like the neuron is a muscle cell. It's not an abstract concept. On the other hand, what differentiates us from great apes and raccoons, squirrels, worms, amoebas, and so forth is largely the abstract symbol systems that we have developed, like science, like language, like mathematics, like engineering practice. And it's arguable that we should be making AI systems that are better than humans at science and math and engineering, at manipulating this sort of symbol system, right? So these two forms of AI have been going for a long time. Right now, obviously certain forms of sub-symbolic AI, such as transformer neural nets, convolutional neural nets, and so forth, are getting a lot of love and getting a lot of attention, and rightly so. They're doing awesome stuff. What's been found in the last few years is by putting more computational firepower and more data behind relatively modest variations on hierarchical neural nets that have been played with for decades. By scaling these up, feeding them more data, we've gotten some incredibly powerful results, which we all know about with the GPT systems and the generative image and video and music systems and whatnot. So that's all amazing. It's also demonstrating some significant limitations. The current neural net sub-symbolic systems that are doing so much in the commercial world, they have a very hard time distinguishing imagination from reality, because in the end, that's not foundational to their architecture, right? They're just predicting what comes next in a series using these sub-symbolic, learning and activation spreading mechanisms. And the difference between imagination and reality is it's not something they couldn't learn in principle, but it's not sort of baked into their architecture in a way that makes it simple for them to learn it. And these networks are also somewhat limited in terms of creativity. I mean, they mishmash stuff that was fed into them at a somewhat surface level, but they're not able to do the sort of fundamental invention that the human mind seems to be able to. So, for example, if you trained a transformer neural net on music up to the year 1900 or something, I mean, it will never invent neoclassical metal or grindcore or even progressive jazz, right? It will just munch together surface level musical patterns from its training data up to the year 1900. And so symbolic AI has been progressing alongside, though it hasn't gotten as much love lately. As an example, my oldest son did a PhD in application of machine learning to automated theorem proving. And to do that, to get AI to prove math theorems, you have a bunch of quite sophisticated symbol manipulation software combined with neural nets and other machine learning methods for inductively guiding that symbol manipulation software, right? So there are domains where putting together the symbolic and the sub-symbolic is the current state of the art. And so where we are now, with sub-symbolic AI doing amazing things with some limitations, symbolic AI still playing a significant role, but not quite as big time at the moment. This has put us at a quite interesting position. I mean, the AI field, is now big time. Every CEO, even the more savvy of national leaders, are thinking about not just their AI strategy, but what is their strategy to get from where we are now in terms of highly capable AI systems toward the next phase, which is AGI, artificial general intelligence, which is a term I introduced in 2004 or 5, which refers to AIs that can generalize and take big creative leaps beyond their training data and beyond their experience. So arguably, with this mix of sub-symbolic and symbolic systems, we are now at a point where we may be just a few years, say 2 years, 3 years, 5 years, 7 years, from a breakthrough from these highly functional but somewhat narrow and specific AI systems, a breakthrough from that toward AGI systems that can really generalize, create, imagine, and take leaps like people. And there's fairly solid arguments that once you get to artificial general intelligence that can imagine and invent and create at the human level, there's a fairly good argument that at that point, you're not too far from the next step, which we can refer to as ASI, or artificial superintelligence, machines that are far more intelligent than people and that can reflect on their own infrastructure and self-modify and self-improve. Because once you get a human level AGI, that human level AGI can copy itself over and over. It can do computer science, it can do engineering, it can do cognitive science. It can build a smarter AGI, which can build a smarter AGI, which can build a smarter AGI, right? So, I mean, we're at the point now whereby combinations of different historical AI approaches we're on the verge of going from narrow AI to AGI. After that, it shouldn't be too long to ASI. But how exactly are we going to get there? How are we going to take the next few steps? I mean, historically, if we're really like 3, 5, or 10 years away from human level AGI, like we're basically there, right? In the scope of human history, that's a blip. But in terms of our own projects that we're building, there's a lot of development to be done in 3, 5, 8, or 10 years, and there's not a consensus on what the next steps need to be, right? So obviously, some folks think you just build bigger and bigger transformer neural nets, and eventually they will make a breakthrough to AGI. I would say fewer people have that delusion now than they did a year ago. I think that the S curve of transformer neural net development is sort of flattening out, but the way radical exponential growth happens is by multiple cascading S curves, right? So as the S curve of transformer neural nets flattens out, the S curve of the next pre-AGI technology is just going to be ramping up, and this brings us to Origin Trail. It brings us to SingularityNet, to ASI lines. It brings us to everyone working to bring together elements of symbolic AI and sub-symbolic systems, because I think the next step is adding on to deep neural nets and the amazing things they can do, adding on systems capable of doing logical reasoning and systems capable of doing more out there creativity. And those two tie together in an interesting way, because being able to do logical reasoning to ground your crazy ideas in factual and empirical reality, this is actually key to having the crazy ideas, because the creative process is one of throwing a bunch of quasi-random stuff out there, which may be much crazier than just surface level combinations of what you've seen during your life. The creative process is about throwing a bunch of random crazy stuff out there and then being able to filter through it by what's grounded in logical or empirical reality. And if you can't do that reasoning, then you don't have a filter that makes sense, and you can't have the liberty of throwing out a bunch of crazy stuff. So I think actually augmenting LLMs and other generative neural nets with reasoning systems that can connect productions with empirical and logical reality. This is not only the key to getting rid of AI hallucination. I mean, it's also the key to building AI systems that are able to have the liberty to create, because they then have a filter. And then if that's the next revolution, it's adding reasoning and then more fundamental creativity onto generative neural systems to move further toward AGI. Then we come back to knowledge graphs and why these are so powerful. I mean, you could build logical reasoning systems, of course, using a variety of different representational substructures. A knowledge graph isn't the only way, but knowledge graphs are the most scalable and the most flexible approach to representing symbolic knowledge that we've found so far. And the fact that they are graphs, just like the neural nets inside some symbolic systems are graphs, that makes it relatively straightforward, though not always simple, to build bridges between the symbolic and sub-symbolic sides of a hybrid cross paradigm AI system. So this then, to wrap up, is how I see where we're positioned in the history and future of AI. I mean, we're coming out of 80 years of development of the AI field, in which both symbolic and sub-symbolic AI have been flourishing and growing in a dramatic way. And I think it's by putting the symbolic and sub-symbolic together, we're going to make the next breakthrough from where we are now to real artificial general intelligence, which will then itself lead the next breakthrough onto super intelligence. It's by putting symbolic and sub-symbolic together. And step one there is putting knowledge graphs together with deep neural networks. And this is to be followed on by adding more and more reasoning algorithms into the knowledge graphs, which is to be followed on by adding more and more fundamental creative generation algorithms into the picture, using the reasoning on knowledge graphs as a filter. So I think we're at a quite remarkable place in the history of AI, and we're all quite privileged to be alive now when we actually get to work on like putting the finishing touches on humanity's quest to create the next intelligent species. And the decentralized AI projects, swirling around this event in this room are playing a critical role in it. I'm out of time, so I'm not going to diverge much into the social and ethical aspects. But in a few seconds, I just want to say, if we're really on the verge of creating AGI and then ASI, as I do firmly believe, it's imperative that this is done in a broadly beneficial and ethical way. And I think having a small elite group rule the AGI as it emerges is probably not for the best of our species. So not just getting neural symbolic AGI to work, but getting it to work on a decentralized infrastructure is really quite imperative to having the next steps of the AI field unfold in the way that's not only intellectually fascinating, but for the best for all of us. And I'm humbled to be speaking to a room of so many people who get most of this stuff already. Actually, these are amazing times.